Good morning, madam. My name is Meghana. I am from Tribly. Today, my topic is simulation of sheath voltage and circulation current in power cable. Introduction to power cable sheath phenomena. Power cable are essential for transmitting electrical energy efficiency. Introduction to power cable sheath phenomena. Power cables are essential for transmitting electrical energy efficiently. Sheath voltage and circulation currents can impact cable performance and long wait. Understanding this phenomena through simulation helps optimize cable design and maintenance. Overview of power cable structure. Power cables typically consist of conductors, insulations, and metallic sheaths or armor. The metallic sheath provides grounding and shielding against electromagnetic interference. Circulation currents can flow within the sheath due to electrical and magnetical effects. Importance of sheath voltage and analysis. Sheath voltage influences the potential difference between the sheath and ground. High sheath voltage can cause insulation stress and a possible failure. Accurate simulations aids is evaluating sheet voltage and various operating conditions. Circulation currents in power cables. Circulation currents are induced currents within the sheet caused by the cable's alternating currents. These currents generate additional losses and heating in the sheath material. Managing circulation currents in the critical for thermal management and efficiency. Factors affecting sheet voltage and circulation currents. Loading variations and unbalanced phases contributed to sheath voltage fluctuations. External magnetic fields and grounding arrangements influence circulation currents. Cable length, configurations, and operating frequency are also significant factors. Theoretical foundations for simulations. Maxwell's equations were the basics for modeling electromagnetic phenomena in a cables. Equalating circuit models simplify complex interactions for practical simulations. Finite element method (FEM) and boundary element method are a common techniques used. Modeling sheath voltage. Sheath voltage is modeled by calculating the potential difference between the sheath and ground. Simulations considers the cable's operating conditions, grounding schemes, and external influence. Results help identify potential hotspots and insulation stress points. Simulation of circulation currents. Circulation currents are simulated by analyzing the induced currents within the sheath's conductive path. Magnetic field interactions due to the AC current influence the magnitude and distribution of these currents. Accurate modeling requires detailing geometrical and material properties. Numerical methods in simulations. Finite elements analysis allows detailed spatial resolutions of electromagnetic fields. Boundary elements methods are efficient for problems involving infinite or semi infinite domains. Time domain and frequency domain Simulations provide different insight into sheath phenomena. Software tools for simulations. Commercial software like NS, Maxwell, COMSOL, Multiphysics, and Opera are widely used. These tools offer specialized modules for electromagnetic magnetic and thermal simulations. Use defined parameters and boundary conditions are essential for realistic modeling. Case study: sheath voltage simulations. A typical case involves modeling a three-phase power cable under various loading conditions. Results relieving sheath voltage distribution along the length and around the circumference. The simulations identifies circular, cir- critical points where insulations may be at risk. Impact optimization of grounding and a cable layout can be reduce circulations currents. Impact of simulations results on a capable designs. Insights for the simulations guide: the selection of sheath materials and thickness, design modification and minimizing sheath voltage influence and circulations current, improved designs, enhanced reliability, reduced losses, and extend capable. Chitti Babu. Huh? Insight of simulation guide: selection of sheath material and thickness. Design modifications can minimize sheath voltage fluctuations and circulations currents. Improve design, enhance reliability, reduce losses, and extend capable lifespan. Challenges in a simulation: occurrence. Accurate material properties and boundary conditions are critical for reliable results. Complex geometric and environmental factors add to modeling difficult. Validations against experimental data is necessary to ensure simulations fidelity. Future trends in sheath voltage and circulation current. Integration of multi-physics simulations for combined electromagnetic, thermal, and mechanical analysis. Development of react Development of real-time monitoring and adaptive simulation techniques. Use of mechanical machine learning to predict and optimize sheath phenomena. Practical application of simulations in simulation techniques. Simulations occurrence and utility. Simulations of sheath simulation and design new cables with improved performance characteristics. It helps in troubleshooting existing installations and planning upgrades. Regulatory standards increasingly rely on simulation data for certifications. Validation against experimental data is necessary to ensure simulations fidelity. Conclusion of this topic is: simulation of sheath voltage and circulation currents is visual for power cable reliability. Advanced advanced compute computational methods enable detailed analysis of electromagnetic behavior. Ongoing research and technology advance will future improve simulation accuracy and utility. Thank you, ma'am.